To learn more about sublithospheric diamonds, we went to Evan Smith. Evan Smith is a PhD student working under the supervision of Maya Kopylova. His paper, titled Implications of Metallic Iron for Diamonds and Nitrogen in the Sublithospheric Mantle, attempts to formulate a model that explains the formation of diamonds in a sublithosphere that contain little or no nitrogen. We sat down with him in the UBC Earth Science Museum and asked him some questions.
Okay, so the Earth is divided up into several layers. Where we live is the uppermost layer where the Earth is rigid, and we call that the lithosphere. Below that is the mantle that's a little bit more plastic, and so the top is the lithosphere, everything below that is the sublithospheric mantle. So the diamonds that I'm talking about are from the sublithospheric mantle as opposed to diamonds from the lithosphere. Sublithospheric diamonds are the ones that form below the rigid upper part of the Earth. And for the most part, they're kind of ugly. They don't really look like what you might think of as a nice gem quality diamond. So quite often they get used for industrial purposes.
To grow diamonds in the sublithospheric mantle, you physically need high temperatures and pressures. Chemically, you want an environment that doesn't have much oxygen in it, because you want a place where carbon can exist as a neutral carbon as opposed to being oxidized like in CO2. Diamonds are also chemically and physically robust. They are preserved for billions of years before being carried by magma through kimberlite volcanic pipes to the surface. It's a very violent journey, and most minerals would be completely dissolved or destroyed. Diamond is special because it can survive that journey. The model looks at the effect of metallic iron in the mantle. Evan Smith proposed that metallic iron content will actually soak up nitrogen. This is seen as it's manifested in diamonds that we have from the lower mantle. The model suggests that diamonds from the sublithospheric mantle have a low nitrogen content in general because they coexist with metallic iron, and as those diamonds form, the metallic iron soaks up nitrogen.
There are a couple ideas out there as to how you might get low nitrogen contents in diamonds. One is that actually nitrogen is incompatible in diamonds, so that if you allow a diamond to grow very slowly, that it should have a low nitrogen content. So that's one explanation.
Thanks to the research of Evan Smith, we can take a step forward into understanding the mysteries of the Earth and perhaps understanding where mysterious sublithospheric diamonds, like the Cullinan and the Golden Jubilee, came from.